So, David is also a former member of PHW's board of directors. Please welcome David Logan.
Thank you, Ed. Thank you all for coming. I'm kind of amazed that so many of you would give up your lunch hour to come talk about lime mortar. I'm going to do my very best to make it as exciting as I think it is. We are a small company. There's about 10 of us. Our shop's up on 600 North Loudon Street. We're in a 1930s produce warehouse. And if you ever wanted to come see our shop, the doors are always open. You're very welcome. So the title of my talk is, the politically correct title, Lime Mortar and Moisture Migration in Historic Structures. Okay, got it. But really, the purpose of me being here and what I wanted to share is I really would like the second title to be the accomplishment of today, is stop doing damage to our Winchester buildings by using the wrong materials. And I don't want that to sound at all critical. I want this to be a conversation and just to share what we have learned and are learning. When I used to be at Universal, we would have to give training courses, and my British boss, this was his advice, and then he stole it from these other people. I'm going to tell you what I'm going to say. I'm going to say it, and then I'm going to tell you what I said, and then I'm going to sit down. And I would like this to be a conversation. Please just chime in if you want to clarify. There's so much to talk about. If we could talk 8 hours about lime mortar, but I promise we will not do that today. So this is what the things I would like to cover. I would like to cover the way I view my, I think of it as my education. I've been doing restoration work since I was 18. I have a picture of the first house I ever worked on. It was built in 1860. I just loved that house. And I feel like if I do this till I'm 85, I won't have figured it all out, because there's just so many complexities of how things are working together in our old buildings. And I think it's valuable. I love what I do because I think there's a value to our built environment. I recently read this book called The Architecture of Happiness, and I really think it matters, the spaces that we're in, like this room. I think it makes a difference. If we were in a cinder block room with white ceilings, it just wouldn't feel as good. And I think humans need that more than we realize. Then I went on a 45-minute walk yesterday around Winchester, and I took about 60 pictures or so. And I just put most of them in this slide that we can go through quickly. The damage to our buildings is pretty high here in our town. And I do not mean, this is what I meant by not critical. I don't want this to be me being critical. I just would like to share, because the industry, the masonry industry isn't interested. The money is somewhere else. This is low volume, low profit part of it, but it's just so important for our old buildings, and we'll get into that. And then I'm going to share with you lime, where do we get it? You can't go to Home Depot or Lowe's. You can't even go to Frederick Block. But it's easy to get. And then we could do a question and answer at the end. My approach and attitude about the technical things we encounter is I always feel like there's something that I don't know and I don't understand. I rarely speak in absolutes. For all the things that we encounter, I always chase people around and ask them questions. Experts in plaster. We just recently worked with a South African plasterer a couple weeks ago. And I just grill everybody, and I get different answers from different people. And I never know, I never feel like I've got the answer. So I'm not up here today to tell you that. But I'm going to tell you the best I know. And I feel like the more I learn, the more I realize I don't know. And it's clear of almost everything. I'm not sure I can say I'm an expert in anything, but I study it every day. And that's why we're members of all these different groups, and we're always contacting new companies that are doing different things, typically traditional. Here is, I think, the crux of what I'd like to say. In the past, we were using lime mortar, starting in the Greek times. They'd take calcium carbonate rocks and they'd burn them, and they would make their own putty that then they would build with. This is lime mortar here. They'd build with and plaster with. It was almost everything in the building besides the structure. We used that for 6,000 years. And then 100 years ago, someone had the bright idea of changing the process. They burned calcium carbonate at higher temperature, and they made Portland cement. And it created a completely different material. Harder, less flexible. We've only been using it for 100 years. And we're doing incredible amounts of damage to our buildings that were built with a former technology. We think our technology, I don't, but many think our present day technology is better. And I think with Portland cement, it's absolutely wrong. It is not better. This is a place called Fountains Abbey in Yorkshire, England. It is a 12th century monastery that Henry VIII destroyed over some woman. And I took that picture. It is absolutely stunning. This is a stone building built with lime mortar. All the roofs are gone. It's getting rained on in Yorkshire, a pretty rainy place. And it is pristine. This place could be restored for millions of dollars, but all of the masonry is sitting there in just fine shape because the lime mortar is doing everything it's supposed to do. The way it was built in 1200s, or maybe it was the 12th century, so the 1100s. It was jaw-dropping, and this has just been sitting here for that long. Little maintenance, it's just sitting there. And these are the arches underneath. No protection from the weather. So water's landing on top and doing whatever it's doing, evaporation, dripping through. So I kind of touched on the value, but the thing I think is important about the world we live in, I think it matters, and I think it affects our quality of life greatly. There's a complicated slippery slope here that I'm not going to go into, but we can't afford to build buildings like this from scratch, and people need housing, and I'm not making that statement at all. But if we thought more for the long term, another reason I went to England was it was kind of an architectural education. And after a period of 9 days driving all over the place, from York to Ripon to Hadrian's Wall, I asked my boss, I said, we didn't see one piece of asphalt shingle. I didn't see any wood siding the entire time I was there. And I said, why are we not seeing these things? And he looked at me like I was crazy. He said, because it doesn't last long enough. So all the investment in this roof that was probably made in the 1800s is still benefiting the people living in it now. It's cheaper in the long run if we would change our perspectives of building quality. And Winchester has tons of high-quality buildings. It's a very high-quality construction here. Lots of brick, lots of stone. And the value, the beauty of a well-designed old building, like this building, is obvious. This is that old house. I used to do black and white photography, and I took hundreds of pictures of this house in every different weather. And this house was built in the 1860s, and it was pretty neglected back then. The first job I ever did in restoration was I rebuilt this corner, and I made lots of mistakes. But working on that house was a pleasure. just thought it was beautiful in a spooky way. We live in an old, fairly old town, and the old buildings that are around us now are the ones that succeeded. So these old buildings, one of the things I love about what I do is we learn from the stuff that's still here. Probably there was twice this many buildings that were built in the 18th century that fell down, because there are always economic balances. And a few years ago, I wrote a piece for, it's called Why Old Houses Last Longer Than New Houses. And I printed out a few if you guys are interested, and if any of you want a copy, I can send it to you. But I think the design is the first factor, and craftsmanship of how the pieces are put together, and then the quality of materials. Those three things go together, and that is the reason that our buildings are still here, because they succeeded in those three items. A 150 years ago, labor was cheap, materials were expensive. So labor was cheap, so they were doing all this elaborate, beautiful, this is that same mansard roof Victorian house that was in the previous picture. Today, labor is expensive, materials are relatively cheap. There's my point. Materials are relatively cheap. We should be using lime mortar, because the material is not an issue. It's not an economic issue. You're still doing the same work. You're just doing it with the wrong materials in this town. That's the Aldi Country Mill, built with lime mortar in 1810 or 12. I remember. It's still doing fine. We did a restoration on it and did some more spot pointing, but a lot of the original mortar was just in fine shape. Okay. The purpose of mortar, I would really, if someone called us in and said, we would like you to restore our house, I would rather walk up to a wall that looked like this than one that had been smeared with Portland. Because that's a Portland wall. You're in much better shape if you start here. Please interrupt on this part, because this is the most important part for the walk around Winchester. The bricks here were made they're handmade, and they're made in a wood-fired kiln. And the ones that end up on the outside of the building are the ones that were the inside of the brick kiln, nearest the fire. They're the hardest, the most resilient. They're the masonry units that were handmade. The ones that were on the outside of the kiln ended up going on the interiors of the walls because they weren't as weatherproof. The mortar is sacrificial. The important part of this wall are the bricks. And these bricks run this way, and these bricks run in. And they're probably tying three, they're called withes, 3 withes of bricks in a solid brick foundation wall. I don't know if this is 3 or 4. But that's how they tie the widths of brick together. So the job of the mortar is, first of all, to transfer structure. But the outer part is to be flexible and to support those bricks. The mortar is supposed to be softer than the masonry units. It is supposed to be softer. If it's harder, the bricks will fall to pieces. And the third job of mortar is it keeps most water out. And I say most because you can't keep water out. There's no way. If we pointed this wall as perfectly as we could, we went over and pointed it again, if it had driving rain against it, it's going to raise it. The moisture content is going to go up. There's just no way around it. Then the other very important, so as water gets in, a very important job of the mortar is to be permeable, to let the water back out. Because the bricks aren't very permeable. They're less so. Handmade bricks are more permeable than new bricks. But ignoring that, this lime mortar will breathe, and it is very vapor permeable. You could, if this were a wall, you could take a hose and wet it down really well, and a few days later it'd be dried out again. And you could do that from the inside too. Yet another incredible thing about lime mortar is it's self-healing. It's flexible. If that wall were to move a little bit, and I'm not talking about a major crack or structural movement, but I've looked at walls that had a 2-inch curve to them. There was an old school in Lincoln, built in the 18th century. It had a 2-inch curve, original pointing, wasn't a crack in it. You couldn't find any cracks, and it wasn't built with that curve. There's free lime available, so when tiny little microscopic cracks form, and the wetting comes, the rain comes, wets the wall, dries it back out, lime moves into the cracks. That's incredible, I think. So if this were pointed with Portland, it's not flexible. It's harder than these bricks. It's not softer. Portland cement's far harder. It's not vapor permeable. The only thing that they share is Portland would keep most water out, but not all. When we walk around Winchester with these pictures, we can talk about these points. This is a 120-year-old house, and it was pointed with Portland, and it's doing everything I just listed. And because it's not letting the moisture out, see how these bricks, the faces are falling off? That's called spalling. The reason that happens is because the Portland cement is not letting the vapor out. In the winter, the freeze-thaw cycle, there's enough water in the faces of those bricks that the freeze-thaw pops the faces of the bricks off. I only see that. I won't say only. I don't really. There's probably an exception. I usually see that in Portland repointed walls. Because this wall was laid originally in lime. Does that make sense? The average moisture content of this wall is higher because of the Portland cement. When I was walking around, I just put this slide in, it's kind of out of place. But this is on Boscawen Street, and you see this kind of brickwork where the bricks are laid really tightly. It's a smaller brick joint. That's a very high skill. That's a higher skilled bricklaying. And the Rouse Fire Hall is laid that way. I just wanted to mention that. It's a very highly skilled work. And that wasn't repointed, so it's in fine shape. While we're talking about brick buildings, I thought we'd talk about log cabins just really briefly. The job of the daubing, this is daubing between the logs. The job is exactly the same. And if you re-daub log cabins with Portland cement, this is Portland up here. Once the damage starts to happen, you take the Portland out, you find big, it's like tooth decay in the logs because it's trapping moisture behind. And this is another picture of spalling. It was a really bad example of the bricks falling apart. So what we're doing is we're mixing materials, Portland cement with old bricks, old handmade bricks, somewhat permeable. That problem's exacerbated. It's why you don't see in new, when the argument can be made, well, Portland cement's used in new construction, you don't have the same failures because new bricks, I'm not saying they're better, but they're less permeable. They're fired in much hotter kilns. So they're not as permeable as the old bricks. So Portland cement's destroying old bricks. That was just a beautiful colonial brick building. Hasn't been repointed. Okay. I just started walking around and it was kind of frustrating actually. This whole building is repointed in Portland. See how you see the wet area here? And right here is wet. when I'd come to these dark areas, you'd go up and touch them. And this was yesterday, and it hasn't rained for more than a week. I did it yesterday midday.
You can find that the rising damp is what you're seeing there. It's moisture coming up from the ground. In some cases, it's not coming down from the heavens. It's
I'm going to argue later that there's no such thing as rising
What was-
damp.
what was the statement? Oh, boy. You
Well-
speak up, please?
He's saying there's no such thing as rising damp, but what I'm saying is that brick is
Thank you.
hydroscopic. It can actually wick moisture up from the ground as well as from the air. But he's gonna prove me wrong, so.
I'm glad you brought that up. I was talking to, there's been some studies in Europe about this, and I have a picture that talks about rising damp. I think this moisture, yeah, some of it is coming from the rain, maybe that's still in that wall, maybe up high that has sunk down. But the studies in Europe say that the moisture in walls that you see like this are because of condensation. And it's just my guess. The condensation, I think, is coming from the damp air from the basement or crawl spaces, for the most part. Not always. West-facing walls, they're going to get a lot of water and a rain around here. And this is a south-facing wall. So I think this moisture is due to condensation from the interior. And the interior, of course, wouldn't have been repointed, so it's going to be very open to the basement air. And they don't think rising damp happens more than about 30, the guy that I talked to said 30 to 40 centimeters. So that much. That's at least a theory. I won't say it's the correct answer.
I have a wall to show it.
Okay.
And you've worked under it. You know what I'm talking about. It's in the tavern.
Yeah.
You had rising damp all the way up to the point where the Portland cement had come off the wall.
I think it's condensation.
But we dug a hole, filled it with gravel, it stopped. We'll talk about it later.
Maybe I'm wrong.
Rising damp is certainly
In 10 years, this talk's going to be way better. Just come back.
rising damp is certainly how we've been taught to understand this particular problem.
I have a picture of a fort that's sitting in salt water, and it doesn't have any moisture higher than the water line. And I could have found 10 pictures like that. I don't know.
Well, the theory
This is a
is
typical
that,
example of, God, I don't know.
the theory is if you replace the mortar with something that won't conduct the moisture out, then it simply rises higher in the wall than it otherwise would have.
Yeah.
And then, of course, it goes out through whatever it can, and if the bricks are softer than the mortar, it goes out through the bricks.
Maybe as long as things are pointed with lime, you can build in water.
Right. That's what we're saying.
Yeah. I thought was a cool thing to see and talk about. It's the old train station. I would love to work on this building someday. I guess that's the office for the train people. Another negative of Portland cement is it's very sensitive to salt. You know, winter salting of your walks destroys Portland cement. Has no effect on lime mortar. You can mix up lime mortar with salt water and use it as mortar. And that's my guess for this. I'm not really sure what's causing this, but this building has been, repointed in Portland. This was an area where actually the Portland cement is further out from the stone. So the stone's being degraded. So the stone's softer than that Portland. Don't you think?
Yeah.
It's just the same picture. There's that fort. During that conversation, and like I said, I don't know, but I found a bunch of pictures for mills. I didn't want to get too sidetracked because I told you we could talk 8 hours about it. But I found a bunch of pictures of lime mortar walls in water, like in sawmills, flour mills, the race walls coming up to the entrances. And the water damage is no higher than, a few inches up above the water. I thought that was fascinating. Now maybe if we went back and repointed this with Portland, it would make it go up.
So,
But
What climate is that in?
that's in Georgia.
Okay, so they don't have too much of the freeze thaw
Yeah,
cycle,
sure.
which probably destroyed the building.
I think most of that damage is from the war. So back to Winchester. This is a wall pointed with Portland. Another thing that's out of context is you can tell this wall used to be lime washed. They used to point their brick walls, and then they would put a protective coating on them. So there's a protective jacket that we no longer put on because we want to leave our brick walls exposed. And lime wash does have some additional protection against wetting,
but it breathes.
but it breathes.
I'd also mention that you're looking at sometimes where they have not only pointed with Portland, they also are sandblasting. So when you sandblast a wall that is made of handmade bricks, you're removing, unintentionally, but you're removing the viscosity layer of the brick, that you're removing that thicker and harder skin to get the paint off and everything else and get it nice and clean looking. And that makes it even weaker so that when the freeze-thaw cycle kicks in, it's even less to fall off when,
Sandblasting destroys walls. There are quite a few very fine houses in Winchester that were sandblasted. I don't know what the solution is. Putting silicone waterproofing is a really bad idea. It exacerbates this whole problem. It traps the moisture in even more, and the moisture contents go up. And if anyone ever tells you use silicone sealant on your bricks, don't do it. The problem is something else. There was another, it's the same problem over and over. This whole wall is pointed with Portland. Old walls were meant to breathe interior and exterior. Moisture comes in. Mount Zion Church, we did some work, some consulting work in. It's a triple thick brick wall. It gets wet, the west facing wall. They used to breathe to the exterior and interior. They went in and put latex paint all over the interior, and now all the latex paint is blowing off to the inside. And I think if they'd have put lime wash on the inside, they wouldn't have had this problem.
That one looks like it might be a flow line, and, there might not be any flashing and weeps to allow the moisture to get out of the wall, regardless of what the mortar was. It just is locked in.
A lot of the modern construction methods of making weep holes and putting ropes in holes, that's all modern to handle water. Back with lime mortar, it didn't need all that. It just breathed through the walls. The walls were kind of transpiring.
and there's also something very important in that picture. There's a basement window that's been bricked over. We seal up our basements, we seal up our cellars, and we wonder why they're falling apart.
It's true, our houses were built with no insulation.
Our ancestors understood, you let a house breathe, especially the cellar. You don't seal it up.
Yeah, it's true.
David, first, with your walk yesterday, taking pictures and stuff, I think the police are looking for you today.
I didn't take any pictures of Oakcrest properties.
What about painting brick?
Yeah.
How does that affect it?
Painting, I am told, I just learned this a couple weeks ago with that South African plasterer, that Sherwin-Williams has a line of paints that are quite permeable, vapor permeable. We haven't figured out what they are yet though. But I have some pictures later of some other kinds of paint, like lime washes. There's a lot of problems with modern latex paints. And I have some pictures of that.
So painting is not necessarily a bad thing as long as you use the right paint.
If you can use a permeable paint, yes.
What if you have a house that's already painted and it's
That's a tough one.
getting ready
Can you
to
repeat
put
the
something
question?
on top of it?
She asked, what if you have a house that's already painted? That's a very tough question. It depends on the budget. You can take that paint off with some gentle soda blasting. You can use some peel away. It depends on what you want to do after. But if the paint is blowing off, it's going to continue to blow off unless you remove it yourself.
With,
And I have some pictures of that.
okay, with what, like a brush?
Peel
something?
away or maybe mechanical with a brush. With soda blasting methods. It's very difficult to get thick paint off of brick because it's so full of crags. This was it's a beautiful brick house on Cameron that I didn't see any issues, so far so good. That's the thing about this, is sometimes houses, you can do a repointing with Portland and you won't see any problems. I'm not sure why.
Well, isn't that, I mean, usually they point to the foundations as the reason. In other words, if you put, with painting, if you put latex paint on the outside and you reduce the amount of, obviously you reduce the amount of moisture which can get in.
But I've seen
And you reduce the
spalling,
amount that
I've
can
seen
get
spalling
out.
on the second floor levels. So every building's different, I think, and possibly these bricks are very permeable. Just making that up. I mean, there's a reason, because that is the west facing face of that building. This is the Rouse Fire Hall, very fine construction. It's lime mortar. I didn't find any issues at all. It's just beautiful, beautiful work. Straight as an arrow, nice tight joints.
David, in that picture you had just before that, what's the discoloration on the base right there?
Right there.
All that
I
discoloration,
think
what
it
is
might be
it?
salt.
It's what?
Salt, I think.
Oh, salt.
I'm not really sure. Salt, dirt, right at the sidewalk line. And you see the same. We looked at brick. Stone does the same thing. These wet marks, I actually went up and touched them, and they're really cool along that dark band. And I didn't see much above this height, on the walk yesterday. So maybe Byron's right.
No.
This was a house that I watched. The mason was very good. He did very nice V-joints. And I called the owner when they had the material stocked. And I said, please don't use that material. It's the wrong material. And he said, and here's the issue, because I respect masons. They work very hard. It's a tough job. He said, my mason's been doing this for 30 years, and he's comfortable with this material. He doesn't want to use something else. So they repointed this whole building just a couple years ago, and now it's for sale with Portland cement. And he did a very nice job. And for about $300 additional, he could have done the whole thing in lime. And see the wet spot right there by the stairs? And this side, this is the west side. It's really bad. And this building didn't used to show wet spots. And the sidewalk's not helping at all, I'm sure. Yeah. But the water's getting in, and a week later, it's staying wet. And if we were in a freeze-thaw cycle, someone is going to pay for this, and it's not going to last 100 years like the last repointing did. This was a wall, I wanted to be fair, this was a wall that looks fine. And I think it's north facing, if I remember right. See how that course, and then not sure what the count is, but these sometimes vary. And that's the header course that's going in and tying to the second width of bricks. We worked on a mill in Leesburg and it had a header course, 2 running courses, or 3 running courses, and then another header course, then 3. So we've seen different styles, and it is a really interesting look, I think.
The fact that this has a limestone foundation above the brick, I think is significant. It's in all likelihood that the limestone foundation, first of all, limestone is not gonna show the freeze thaw problem as quickly as brick will. It's a much more durable, much stronger material for obvious reasons, but it also, I'm sure that wall has, well, I don't know. You
That foundation was repointed with Portland.
Okay.
This whole thing's Portland cement.
Right. But it's still, we're looking at limestone as opposed to brick.
Yeah.
Which is significant, I think. It's not as hygroscopic as bricks are.
Yeah, but there's other limestone pictures in here that show the same thing. This is a very, very old pointing. You can see the white. And then someone went back with Portland cement and just smeared the repair. That wasn't a great grouse bin. You know, where most of the work we're looking at is, like that last stone house.
Is the white Portland or?
No, the white's lime. White's original. There's no reason why they couldn't have matched it. And if you're interested, my supplier talks about how hard it is to import this white powder into New York. But this is French. It's from a quarry called Saint Astier that the Romans opened. Then I think it went dark for 1,000 years or something, and it's open again. This is Saint Astier lime. And I don't know if you're interested in that.
Can't you get hydrogenated lime? Not good.
You can't. It's burned at too high a temperature. Old lime was manufactured at over a wood fire, about 1,000 degrees.
I thought the place in Virginia did that.
Yeah, they've outsourced all of it, and their lime quality has gone way down. The very best stuff is at least available. You can get good available quantities are from there.
What's it cost? 5 pounds?
A bag costs about $35.
Or 10 pounds?
No, it's a 50-pound bag.
David, that's the product that you're gonna mix lime mortar on, not lime putty?
No.
Why is that?
Lime putty. I told you we could talk 8 hours there.
Yeah, but the only experience I've ever had was with lime putty.
So lime mortar is made by taking calcium carbonate rocks of a certain quality, and I don't understand all the ins and outs of it. And they burn it at a controlled temperature, low temperature. And that becomes a reactive, very light rock. And then they put it in water, and it turns back into lime putty. Lime putty historically was used by plasterers. In the 70s, they were using lime putty on laying, but that's not what masons used. And I have some pictures. They were using the calcium oxide ground up, mixing it with sand, and they did what was called a hot mix. They would mix water with the sand with the quicklime, and it would get hot because the reaction happened right then. But that's what they were using to lay. This is quicklime that has then been re-dried and put in bags. So it's reacted already.
This is what this is.
That's been reacted, and then, so it's not dangerous. If you mix it with water, it wouldn't have that.
So no one's using the correct line, so this is very hard to get.
Not hard to get. But you're right, no one's using the correct line in Winchester.
David is, and I can't remember if this is the case or not, but Department of Interior's preservation briefs, they talked about the mortar. Did it say something in there about using Portland cement or cutting wood line?
Yeah, I think they've changed that.
They've changed that?
I think so. It's been discussed for the last 5 years that it's wrong. People in the Park Service aren't using it. They had a recipe of, I don't remember now. 1 part Portland, 1 part lime, 5 parts sand, something like that. As soon as you put Portland into a lime mix, it loses its plasticity, permeability, self-healing, all of those qualities go away. And all the people in the National Park Service I've talked to say, yeah, we know, we don't use that recipe, but it's been online for 5 years.
What about the local lime companies lowering the heat?
Yeah, I think Virginia Lime Works was talking to some people about doing that, but their lime is not from as pure a source as the calcium carbonate from St. Astier, and it gets these really spooky, scary, like green colors as it's setting. And for us, it's like, oh, shit, our reputation's on the line here, and it turns this weird color, and then it goes white, and it's got some impurities in it. I think it's probably something about the burning process.
What's quality rocks? I mean, I look at these lime rocks all the time. You get the gray ones, you get the light gray or the dark gray? Blue?
It depends on the region, because you're getting into an area that I can't speak in detail about it. But because of different elements in it, like magnesium, or I'm not sure what, chromium, some of the lime will set underwater, some of it's hydraulic, some of it's air. And in different places, you can get mixtures from the same quarry, so the quality control is very difficult. 150 years ago, the guys that went down to the lime kiln road and got their lime knew what that lime, how it was going to act. They got to know their local lime. Those kilns are now closed. Whatever they were using, I think there's one down in Stevens City, but they're no longer quarrying it. So, for my caution, I want to use lime that I know how it's going to act. And the quarries that I wish I could get to are no longer operating. Does that make sense? Some limes can be set underwater. And others you can mix up and leave in a bucket as long as you put the top on and you don't let CO2 get to it. They'll stay. They'll stay good. Others will set in the bucket. Yeah, this wall, we've, in the historic standards, you don't want to go into a place and tear out all the original mortar. You want to leave as much original as possible. And so much of this wall is fine. It just needs some spot pointing. And you could have gone over the whole thing, saved the job a ton of money, left what was good, and just replaced. I assume there was a crack there or something. But there's some pointing here that needs to be filled in and done. And
Well, again,
I think-
David, in the preservation briefs, I think they say for repointing that you're supposed to rake out the joints like 2 inches deep. So you're saying that's not a good thing to do?
the way I was taught is that the joint should be cleaned out twice as deep as it is wide. So if it's a very thin joint, 1/4 inch, you only have to go in, about a half. And if it's got a void there and a cavity, as long as you're not pointing over dust. Oh, that's another important thing. Lime mortar is persnickety in one area. And Joel and I have worked together on trying to figure this out a little bit better. But you have to keep it wet. You've got to keep it wet for 7 to 10 days. So before you point this wall, you've got to hose it down. We think you have to hose it down for all day because that wall will take a lot of water. You can't just go up to a dry wall and put lime mortar in it because it will turn back to dust and fall out. We have had failures. Learning the hard way. It's great education, I guess.
So when you go up to an existing wall, like the very first picture you had that showed the mortar was worn away,
Yeah.
the first thing everybody does is they take a pocket knife or a screwdriver and start opening the mortar. How hard should that lime mortar be? Should you be able to, with a screwdriver, scrape it out?
Absolutely. I was scraping out some yesterday on my walk with my fingers. I actually took a video, but it won't play on PowerPoint. But I have a picture of that. You can walk up to this wall, making a mess. But it's soft. If you look at these walls, you can see the lime chunks. Those are called lime inclusions. It's a result of that hot mix. If you were mixing up this with lime putty, you wouldn't have that. It would be consistent. Plasterers, they were using the best because you used to pour this quicklime in a pit on the job, and then they would fill it with water, and then they would cover it up and leave for 2 years. And that lime in that pit would settle out. The hard stuff, the coarser stuff would go to the bottom, the fine stuff would go to the top. The top was what the plasterers would skim off and use. This was, at the very least, I thought, if you're going to use the wrong material, you should at least match the color. The reason lime, often lime mortar, you walk up to it and it's got this nice cream color. The reason it's that color is because of the sand. And probably if we walked along the town run and we found a sandbar, that probably mixed with that lime in that bag would match this color. Because they didn't go far for their sand. It was just too much work. And so that's really how you can get a very good color match. Is just try to experiment with local sand if you can. And if you can't, there's an even easier way, which I'll share with you. We get our lime from a place called Pennsylvania Lime Works. And I have contact information for you. The guy, I really trust him. He's a mason. He loves this stuff. He's one of the guys I've chased around asking lots of questions. And he just loves it. And he's not selling it because he's a salesman. He's just selling it because he believes in it. And he's just gotten my trust. And they sell or distribute the St. Astia lime, and they have pre-mixed bags with sand in it that he can make for you with color matching. It's very easy. He's got a little kit with a bunch of different colors in it, and you can use that kit to get your color close, or he'll custom mix the different colors. So you can buy it pre-mixed for the color, because we can't afford to go down to the local stream and dig our own sand out. This was a wall that was on Loudon Street, and it reminded me of the one in Fredericksburg, where it could be brought back to life very quickly. You'd clean it out with a brush, then you'd wet it down, then go home, come back the next morning, probably wet it down again, and then start pointing, as long as it's not soaked. And this, I think, I'm not sure if it's paint. If it's paint, it's at the end of being blown off. But most old walls, you see remnants of lime mortar. And that is Richard Bell's cabin on South Loudon. And most of that's Portland cement still. But, it's so far so good. It's probably hiding. Portland cement tends to hide problems. Don't you think?
Yeah, but when you're talking about chinking between logs, it's, as you described it as tooth decay when you take it out. Anytime you are going to make it so that there's moisture is trapped in a place where there's wood.
Yeah. And Byron always tells me wood is food.
That's true.
We're building our houses with food. But this, we got to repair this one, the lighter colored ones, because we had to do some log repairs. There was rot going on. So these now are all lime mortar. It's that same. We used cream colored sand and white mortar. And I thought a great parallel, and this is a cabin we're doing in Loudon County. It's an 18th century cabin. It was listing badly, and the owners asked us to straighten it up and tidy it up. It's been a lot of fun. I thought a great parallel was the way they're building in, built in England. I think that's the date of this building. Or at least it's close, if it's the address. But this lime mortar up here is doing exactly what it would do in a log cabin. And look how everything's in fine shape. If you Portland cemented this wall, that woodwork would fall apart in 25 years. But because it's it's allowed to dry. And this is in York, England, so they get lots of rain. I thought that was an interesting parallel with log cabins. Same function of the material. And also, Portland cement would never withstand the movement of a wood building like that. This, on the walk, I came out on this wall, and it is latex or oil paint. And it's doing what all latex and oil paint does on old masonry. It looks like it's been doing this for a while, because it's just blowing off. So, historically, walls were whitewashed. And whitewash was just lime and water. And you could put pigments in them to make them a color. Like I said, this whole education is having to be relearned in the 20th century, starting in the 20th century. Because we lost this technology. We thought that we knew better, and we left it. So masons starting in the 60s and 70s and 80s. And Scottish Lime Centre in Scotland has been a leader in this. It's trying to figure out what we've lost. Because like everything, the more you do something, the more you realize there are tricks and nuances to it. And so all the people that knew this material were then dead. We've had to kind of relearn it. Hopefully some of the traditions remained around the world. I don't know how all the knowledge has come back, but we're still on the learning curve, though, I think. At least I certainly am. But we've started using a lime-based paint called potassium silicate. One of the manufacturers' name is Kime. Probably heard of Kime. And Pennsylvania Lime Works has their own version of silicate paints. Chemically, they bond to the silica in the wall. So they have what I'm told is a quite tenacious bond, and they're very breathable. And we did this on a building on South Loudon that Larry Belkin designed. So I'm excited. This is the first job we've used silicate paints. But a lot of other people, I don't really jump into much. I don't use anything really unless the technology is older than 200 years. And even with that, I tread very cautiously. So I ask a lot of people lots of questions. And we got this material from Pennsylvania Lime Works after harassing the owner a number of phone calls. But you can get it in all colors, and I'll be very interested to see how that holds up. That's the same. This building had never been Portland cement pointed, so we just did spot pointing. We had to do a lot of mechanical scraping on this. We actually had to use peel away on the front. It was so thick. The front had been painted many more times than the sides and back. So we used a chemical called peel away. It's a strong base that it's a nasty process, but it turns the paint to goo. And we basically just scrubbed it off. And then you power wash the goo off the bricks, gently power wash.
Is there a different peel away for bricks and for wood?
Yeah.
So you don't have to put the paper layer on?
I think you do have to use the paper. They may recommend peel away 1, but I call the company often and say, which one do you recommend? And they often recommend peel away 1. That's the one you typically use. But they have many different grades. This is the old jail, and it hasn't been highly affected by repointing. There's some really unmatched pointing in the end, but that building's still breathing. And it's in very fine shape. When was that built?
Lady,
Then I was just walking up the walking mall, and it's kind of more of the same. This building was very wet over there behind that little cart. And it looked to me like the bricks are really starting to deteriorate low down. especially through the winter we just had, so much hard freeze thaw.
What's the easiest way to tell the difference between the lime mortar and Portland mortar? Is it just the lime is easy to flake off?
This was I'm sorry that didn't work, but I took a video, and this is on the Sullenberger building. I walked up to it. See these lime inclusions? That's the hot lime, so we're mixing it dry. I walked up to that mortar joint, and I just did this. See how different that looks from that? I just did it with my hand. I could have gone in 1/8 of an inch if I kept doing it. If you walk up to mortar, and it has lime inclusions, and it's kind of soft, and you can affect it with your fingertips, it's lime mortar, chances are.
You can feel the difference between that and Portland.
If you go up to Portland, it's like these tiles. I mean, it's rock hard.
It's hard as a wood.
Yeah, rock hard, and you won't scrape any aggregate out of it. I don't know what to say about these next few slides. Sullenberger building is a beautiful building, and all of the rework was done with Portland cement. It not only was the wrong material, but it doesn't match at all.
And they parged it with Portland at the bottom.
David, do you know when new construction, new masonry construction in Winchester became almost universally Portland cement? In other words, when did if the buildings from 1890s or 1910s or 1920s, is there some cutoff point where you can say, oh, if this building was built after this date, they were using Portland
I
cement?
don't know the exact date, and the reason I say that is Portland cement started to be used in the big cities kind of late 1800s. Isn't that the date you think of in DC and New York? And a lot of the builders, probably like our company, didn't embrace it. They kept building with what they knew well into the 20th century. So I think we've looked at buildings built in the 1920s that were still lime mortar. So I don't know the answer.
When did they abandon the honey, the beehive kilns so that they had, the gas fired?
Yeah.
I mean, because when the brick became different, it fit together. With modern construction, I don't think you'd want to build a new brick building with lime mortar, not today, with the bricks that are available, would you?
I think it would be fine to do that. The other way around is the real problem. If you use Portland cement with old bricks. But I don't know when the kilns. I don't know when lime kiln worked.
There's articles you could read on the subject of the history of brick technology, but it is very rapid succession in the 20th century that you start to see these changes.
Yeah. This building, I just don't understand it. Unless that's an architectural statement.
Amazing.
The right material was available, and the masons had to do the same exact thing. And, I'm not sure what to say.
Where is that?
That's the Sullenberger building.
Oh.
Just done, a couple of years ago. And, they use new bricks and
Sealed up the basement.
I said I wouldn't be critical, but that's a whole lot of not caring.
Yeah. Or not knowing how to care in some cases.
It's pretty in a strange way, but the other thing I wanted to mention was Tim Machado, a local architect, taught me this. The method of putting these capstones on used to be set in lime mortar, and when they started putting them in Portland, these things would break. So now all up and down our walking mall, we have these things set in caulking, and then the joints between have to be caulked. I thought that was interesting. I just learned that from him. This is where we get it, and like I said, I just really think a lot of these guys, they help us technically. They put up with all my questions. They're nice people, and they're the kind of people that say, they'll tell you when you don't need something, if you guys are interested in that.
And they'll tell you their formulas.
They'll give you lots of technical, yeah, that's the thing I like about it, is there's nothing secret. They're not putting voodoo in these bags. They're putting lime and sand and pigment, and they'll tell you what's in there. That's the thing I don't like about Virginia Lime Works, is they wouldn't tell you what they're doing.
Proprietary.
Yeah, and it shouldn't be proprietary, because it's lime and sand.
Is there a difference between the interior bricks and the mortaring? Because most of your pictures have been on the outside from your walk, obviously, but on your inside, if you're talking about pouring water on it, you know, and things of that nature, you use the same technique and the same process?
No difference. Historically, the inside was still a breathable coating. The only difference would be that you could use what was called salmon bricks, the outer bricks from the kiln, because they weren't as resistant to moisture. You could use them on the interior. Mortar was the same. They'd build these walls all at the same time.
Right. What was that you called it? What did you call
Salmon
it?
bricks. Salmon?
Yeah.
It's just the lighter colored bricks that don't get fired as hard. Ed's told me to pick up the pace, and that's it. And if you're interested, I'm a newbie at this. Not a Luddite, but a newbie. We're putting pictures on our Facebook page of jobs, and I'm hoping to put lots of historical work.
David, will the lime mortar for the Winchester Little Theater restoration be coming from Pennsylvania?
Yes. Yeah.
Getting the good stuff.
Virginia Lime Works used to share the distribution of St. Estier lime. I'm not sure, Maryland South, and Pennsylvania Lime Works did Maryland North. Virginia Lime Works decided they wanted to go proprietary, so they dropped it. And Pennsylvania Lime Works picked up the whole country. He didn't go for that, he didn't even ask for it. But sure, it must be a wonderful thing for him, I would think. It's still a very small market, though.
I found this very interesting. I did an expedition a while back in Mexico, and it was for, we were mapping conquest period architecture. Basically the Mayan pyramids and the Mayan ceremonial centers, because it's not just pyramids, there are all kinds of structures for homes, etc. And they were incredibly, these are structures that were not fully excavated, so they have growth on them, etc. And I was always fascinated, like, how these sustain thousands of years in this kind of environment, because it's out in the open. And it turns out that they're built out of limestone, and they had, I guess, your version of a lime mortar between them. You know, so that I just found that incredibly fascinating. There are also no above-ground water systems. They said the entire Yucatan peninsula is a limestone shelf.
Really?
Yeah. Very dry, very humid, and no above-ground water systems. But those pyramids are everywhere. And I mean, we were not in the tourist areas. We were in the villages and in the rural areas where there were a lot of them, completely covered by earth, partially unearthed, etc. And they were very, very much intact.
I would love to see that.
Yeah.
So that's very much like that place in England, completely unprotected.
Right. When I thought of that right away, and I was trying to map, like, what's this time period? And it was about 2000 BC.
2000 BC.
When a lot of these were built.
And we know better.
So I guess one question is, how do we fix it? Let's say if our wall has been repointed with Portland cement, how do we go back and stop it from failing?
It is an expensive, unfortunately, it's an expensive proposition for the owner the next time that they have Portland. Because that Portland cement is very difficult to get out. It really has to be taken out by hand. Very carefully, you can run a grinder down the middle of the joint, which gives it a place for the mortar to break away by hand. But you can tear up a wall with a grinder because you'll hit the bricks if you're not careful. Just the important thing is that the next time it's pointed, it has to be pointed with the right material. And I've been quoted numbers like $20 a square foot for some of those walls that look really intact to get that stuff out and then repoint. The buildings are way better off if they were never maintained. Preservation by neglect is a way better situation than this.
How would you grade the work in this basement?
It looks very lime mortar-y right here. It doesn't look like they tried to change the interior. Right, John? You left it alone.
Right.
I wasn't talking about the overall interior, I simply talked about the walls.
Yeah.
Yeah.
The walls, they don't look like they were repointed at all. Which is a good situation.
The mortar between the bricks of my office building, which I believe is late 1790s, was crumbling terribly. You just dig it out. It's been painted many times, but the mortar's never been changed.
Well, that's good.
Can you add lime mortar to a crumbly surface?
Not a crumbly surface. That's another wonderful thing about lime mortar is it will bond to itself 150 years apart. So as long as you get out the loose, you can't point over dust or there won't be any. Get out the loose and wet it. The wetting part is very important. Then the old lime will bond with the new. It's a compatible material, idea when you go back into an old building. Use compatible materials. So you're in very good shape there. And a lot of masons are resistant to this, and I really hope this group can help gently introduce these ideas, because a skilled mason, like the one that did that stone building, can easily do this with just a few little tricks and tips. But they're not selling it at Frederick Block. And I'll say, nor do I think they care. So I would be very happy if any of you called and said, "Can you help us get this?" Because we order from Pennsylvania Lime all the time, and we could combine and order, or maybe we have the material up in our warehouse that you can use, because you need a surprisingly small amount of. In some jobs, it's just a few bags.
Any further questions? Thank you, David.
The price differential, I'm curious about that between the Oakwood mortar and.
Yeah. Remember I said today labor's expensive, materials are relatively cheap. I have never bought a bag of Portland, or it has been for a long time, but I think they run about $12 a bag, 50 pounds, $15 a bag or so, and a bag of lime is about 35. So it's double. But you only need, like on that brick house, that stone house, he probably only used, I don't know, $400 worth of Portland. And he would have used $800 worth of lime. So it's a $400 differential. And he probably spent $15,000 in labor.
15,000.
Those are my round numbers. Relatively, it's very, very small. And I think costs, they're an important factor. But the cost difference isn't enough to factor.
Thanks a lot, David. This is